These are the notes for exponential growth and decay uh, for IB Math. So this is a little review warm up. To start with, you can pause your video here and see if you know how to answer this. So you're getting paid 100 a week. You get the first week, and then you get a 2% raise each week after that. It says hint find R. So if you think about this, the first week you would make $100, and then the second week you would make 2% more than that. So the shortcut to that is to multiply by 1.02 because that's 100% plus 2%. And so you can keep doing this each time and figure out how much you make at the end of 10 weeks. And so it could be kind of tedious if someone said, how much would you make at the end of 50 weeks? So we need to have a way to figure out a shortcut for that. And so the shortcut would be to figure out a formula. And so this is a geometric sequence because we are multiplying by, the hint you saw was to find R. We're multiplying by 1.02 every time. And so you set up this little formula. Now, this little formula, this is the first term. This is the common ratio. And we do this n minus 1 so that when we plug in 1, you get 1 minus 1. That makes our first term be 100. Sometimes this is going to be n, and sometimes this is going to be n minus 1. And so you always just check to make sure you pick the right one. This is you're getting paid at the end of the week, so none of the things happen. And then if you wanted to find the sum of all those things, you just use your sum formula. So there's your common ratio. And you can figure out 10 weeks how much you made. Altogether, you made 1,094. Okay, so we got two things we're looking for. Is it growth or is it decay? And so if it's growth, you're going to have 100% plus the percent, or 1 plus the percent. And if it's decay, you're going to subtract. So this is rabbits. So they're increasing by 7% each week. So our R would be 1.07. And so it says the initial population was 50. So if you think about this, we're looking at 50 plus, or the next one would be 1.07 times 50. And then 1.07 times that, 1.07 times that. So I'm going to show you on the Wabbit here how you do that. Isn't that ironic? We're going to show you how to do the Wabbit problem on the Wabbit. So this is one where you have to be careful. You have to do 50 times 1.02. Now, if you just try it, some of you have a calculator that will make an exponent. If you don't, you have to put it in parentheses. But if I do to the n minus 1, I'm just going to go to my table and make sure it is right. So when I go to my table, it says year 1 is 50, or week 1 is 50. Well, that's at the beginning of, we want the beginning of the week to be 50. It says after each week. So I need to go back and change my y equals to just make it to the x, and then it will line up the way I want it to. So if you once you enter an equation here, you go back to your table and it shows you. So after 1 week, there'd be 51 rabbits. And then 52.02. So this 50 is really a year 0. So if you wanted to do the n minus 1, you do 51 times 1.07 to the n minus 1. So once you have it set right in your calculator, 15 weeks, you can just go down to the 15 weeks on your calculator. Touchscreen's being a little touchy. So it'd be 67.3. So like 67 or 68, 30 weeks. You could go down there and find out. The other question here is, how long would it take for the population to reach 500? So we want to know when y is 500. There's a couple ways you can do this. one way would be to graph it. In the interest of not making this video too long, you're really graphing the equation we did, y equals 50 times 1.07 to the x, and you're graphing y equals 500, and you're seeing where they intersect. The other way you could do it is 50 times 1.07 to the x minus 500, because that would be solving. That'd be setting those two equal to each other. You could find out when y equals 0 there. We'll talk a little bit more about solving later on. You also could just scroll down until you get to 500. I just didn't want to do that on here. Okay, so the nest of ants contains 500 individuals. The population is increasing by 12% each week. So right now we have 500. After the next week, we'll have 1.12 times 500. So again, similar question because it's an increasing value. So we can go to the calculator and just edit. And so this time it's going to be 500 times 1.12. And I have it, I'm going to keep it to the x. So I'm going to go check my table and make sure it lines up right. So all you got to do is check that first term and make sure it makes sense with the problem. Not anything to memorize there. So right now, at week 0, we have 500. So that's what we want because we're starting with 500. At the end of each number of weeks, then you can answer the question. And if you don't want to learn how to solve, you can just scroll down until you get to the right amount. So at 10 weeks, there's 1,500. At 20 weeks, so forth. It says how many will it take to get to 2,000? That you can actually see on this one pretty easily. Somewhere between 12 and 13 weeks. You'd have to stay 13 weeks because at 12 it's not quite there yet. So somewhere between 12 and 13 weeks it would happen. A farmer buys machinery for $25,000. The machinery depreciates at a rate of 8% per annum, and per annum means per year. So in this case, we are going down in value. Depreciate means lose value. Most assets lose value. So right now it's 25,000. After a year, it's 25,000 times. Now this time, 100% value would be 1. We're 8% less than that. So this time we subtract from 1. So our value is 0.92. So 92% of its value, and then 92% of its value, and so forth. So let's put it in the calculator and make it work. So it's $25,000. This time it's 0.92 to the x. Again, I'm going to always check my table because on that warm-up, it was n minus 1. So right at year 0, it's 25,000. Now you can see how much after year 1, after year 2, after year 5, it's 16,477. How many years before it's worth half the original value? So in other words, we're looking for when is it worth 12,500? After 8 years is 12,800. So somewhere after 9 years, it would between 8 and 9 years, it would reach that value. And depreciation is actually a legal thing. When you own a business, you do this with all of your assets because you claim them different expenses on your taxes. So one of the things in business that you want to show that you're making less money than you actually are because it saves on taxes. Depreciation is there's actually legal tables. You're allowed to depreciate a certain amount and not allowed to depreciate another amount. Petra buys a camper for 45,000, whatever those are, pounds. Each year, the camper van decreases in value by 5%. How much would the camper van be at the end of 6 years? So 45,000 is our initial amount. It's really like year 0. So that we're decreasing in value by 5%. So our R value is 0.95. So again, going back to your calculator, 45,000, and this time it's it's 0.95 because it's going down by 5%. So if you go to the table, you just double check to make sure. Yep, 0 is 45,000. So you can see after 5 years, it's 34,820. If you ever get stuck on these, you can just keep multiplying by this value and make a list. If you can't figure out the calculator, it's only 5 years. You have a calculator to multiply. Just keep multiplying by 0.95 and you get your answer. Okay, so the next thing I want to show you is the connection between compound interest, and we've been using the finance app, but compound interest is a geometric sequence. And so like using that formula that we talked about, we mostly used our calculator. If you invest $25,000 at 8% compounded question mark times per year for n years. This is how it goes in the formula. So when you're doing this quarterly, it raises it to 4 times as many values. But if you notice here, this is just a number. So from that formula, we always divided that. So this is our R value, and it's happening 4 times a year. If you change that to monthly, you'll notice that this R value still above 1, but it's not as big as this R value, but it's happening 12 times the number of years, whereas this was only happening 4 times the number of years. Again, though, this is beginning value times R. And then if you did it just annually, that's once a year per annum. This is the highest multiplier, but it only happens once a year. So when you're using the TVM solver, some of you might be able to figure out how to do some of these exponential with the TVM solver. I'll let you play around with that if you want to. You just have to be careful with your compoundings. These aren't that complicated that you need to do that. But that's not some kind of a magical secret program that's built in. It is just figuring out this ratio for you. All right, so go ahead and pause your video and see if you can figure this one out on your own. So we buy a car for 30,000 and it depreciates for 25%, and then after that it's 15% a year. So after how many years will be worth less than 10,000? There's not a good way to do a formula here. You can if you want, but 30,000, it's 75% of its value. So after 1 year, it's worth 22,500, and then each year after that, you take it times 0.85. So it's not consistent, but you keep multiplying it. See how long it takes us to get to under that. So after 5 years, it's worth less than $10,000. Remember that exponential growth and decay, if it's growth, you add. So it's 1 plus whatever the percent. If it's decay, you subtract 1 minus. That's all.